So let's try these two definite integrals here today. So here's what I would do. I think they want us to use a U-substitution. So for a problem that looks like this, I'm gonna let U equal, not the entire radical expression, but just the stuff that's inside of the radical, that there. And then once you assign U, usually that, we automatically have to find du. So we take the derivative of U. So let's ignore this. So the derivative of 7 is 0 because it's a constant. And the derivative of that would be negative 2x dx. But let's look ahead. What are we about to do? We're going to rewrite this. Instead of x's, we're going to use u's. Now, I do have something that'll replace this. That is u. But here, the dx is there. And I have x here and x there. But that says 20, and this says negative 2. So we are allowed to get creative and to multiply the du by whatever we want. In this case, I'm going to multiply the du by negative 10. And let's see why that helps. Because that'll be negative 10 du, like that there, equals negative 2 times negative 10 is positive 20x dx. So with this very clever manipulation, we have something that can replace 20x dx, this here. So let's rewrite this here. So that's there. So let's see. What if I do this? What if I draw a fraction? But in the denominator, it's a square root, but instead of that, which is that, I'm going to use u. So that's just u. Now, what's left to replace? I must replace 20x dx. But that entire puzzle piece is just negative 10 du. So I'm going to put negative 10, and then I'll put the du right there. Now, for right now, the limits of integration, I'm going to ignore them. I'll leave them blank. There's something that we could do to change these numbers, but I plan at the end of this problem to rewrite everything back in terms of x's. So watch, let's go along for the ride. Let's kick the negative 10 out to the front, like that there. And I'll just put like 1 over square root u du. And then let's see, so square root of u, that's the same as 1 over u to the 1/2. And that's the same as u to the negative 1/2 du, right? If I bring this to the top, the exponent changes from positive to negative. Now recall your integrals. So far, we haven't really done any calculus. This has just been algebra. Now is the time to do some calculus. What is the antiderivative of u to the negative 1/2? That would be u to the negative 1/2 plus 1 divided by negative 1/2 plus 1. And we'll keep the negative 10 in the front. And let's see what happens. Remember that? Because you have to add 1 to this, and then you divide by that new power. So let's see. So that's negative 10. And this is going to be times u to the 1/2, because that's just 1/2, over that is going to be 1/2. And then if you type that into a calculator, if you go negative 10 divided by that, it's going to be negative 20 u to the 1/2, which is negative 20 square root of u equals. Now what we can do is we can bring the value of u back in, which was 7 minus x squared. However, this expression, it has to be evaluated. Maybe your teacher does it something like that. They draw like a bar, and then those original numbers, they get dropped there. You see what I'm saying? So before we finish this problem, let's recap. We created a U-substitution where u can equal, in this case, the stuff inside the radical expression. Take the derivative of u as du. Oftentimes, we do a manipulation of this equation to make it to match to whatever the original problem says. That manipulation is key. Then rewrite in terms of u. At some point, to do some algebra, take the antiderivative and bring the x's back in. And then you finish the problem by evaluating at the original limits. So you do that by plugging in 1 into there, and then minus, and then plug 0 into there. So watch. The first bubble is whatever I get when I plug in 1 into here. That'll be like that. That'll be like that. Okay. So that's 1 plugged in there, minus, and then plug 0 into there. So that'll be negative 20 square root 7 minus 0 squared. Now watch, I completely made up this problem, so I have no idea if the answer is going to be nice or not. But your problem, because it was created with a little more thought, might have a nicer answer than mine, because my final answer is 20 square root 7 minus 20 square root 6. I could turn that into a decimal if I wanted to. I'm not sure if they want you to, but for my example, that's my exact answer. I'm willing to bet that your answer for your problem is going to be a little bit nicer than that, but I'll leave that to you to find out. Kind of the same thing. In this case, I'm going to let u equal the stuff in the parentheses, the stuff that has the power. So that would be 4 plus sine 2x. And as soon as you create a u, you find your du. So the derivative of that is 0. What's the derivative of sine? Cosine. But this is a chain rule. You take the derivative of sine, that, but then you multiply by the derivative of the inner function, which in this case is 2. And let me put the 2 right there in the front. So this is du equals 2 cosine 2x. Now let's look ahead. I know that this is going to get replaced by u. Power 5 is still going to be there. Now I need something for cosine 2x dx. Put a dx right there. Should have put a dx right there. So what can replace cosine 2x dx? Cosine 2x dx. But that 2 is not desired. I don't want that 2 there. So what you can do is divide both sides by 2. So that this is 1/2 du equals cosine 2x dx. So that now that gets perfectly replaced by 1/2 du. So let's rewrite this. So I'd have that becomes u to the power of 5. And then instead of all that, which is here, I have 1/2 du. I'll put the 1/2 outside because it's just a constant or a coefficient. So this is what we have. Instead of this, we have this. Now let's do the actual antiderivative. 1/2 stays the same. Now what's the antiderivative of u to the 5th? It'd be u to the 6th over 6. And this would be 1/2 times 1/6 is 1/12, right? Because you can multiply those. And instead of u, let's bring that expression back in to the power of 6. Now this here is supposed to be evaluated from where to where? From 0 all the way up to pi over 3. So let's plug in pi over 3 in there, and then let's plug 0 into there, and we'll drop those values in here respectively. And in my calculator, I made sure that I was in radians because we have pi's, and I typed all of that in, and I got a crazy answer, 764.95. And again, this was my answer for my problem that I made up. I don't know how clean your answer is going to be. I'll let you find out. But apply the same general technique, and it should work out.